there are several modeling systems and approaches used in supply chain management. Here are some commonly used modeling systems in the field. 1. Network optimization models. These models focus on optimizing the configuration of the supply chain network, including the location of facilities, allocation of resources, and transportation routes. 2. Inventory optimization models. These models help in determining the optimal inventory levels, reorder points, and safety stock levels to balance customer service levels with inventory costs. 3. Demand forecasting models. These models use historical data, statistical methods, and forecasting techniques to predict future demand patterns and help in production planning and inventory management. 4. Simulation models. Simulation models mimic the behavior of the supply chain system to evaluate various scenarios and assess their impact on performance, such as production capacity, lead times, and order fulfillment. 5. Discrete event modeling. Discrete event modeling involves modeling individual events and their chronological sequencing to simulate the flow of materials, information, and resources in the supply chain. 6. Agent-based modeling. Agent-based models represent the interactions and behaviors of multiple entities, agents, in the supply chain, such as suppliers, customers, and transportation providers, to study their collective impact on the system. 7. Markov chain models. Markov chain models are probabilistic models that analyze the transition of a system between different states based on probabilities. They can be used to model the movement of inventory or the availability of resources in the supply chain. 8. Queuing theory models. Queuing theory models are used to analyze and optimize the flow of entities through queues or waiting lines, such as the flow of orders through production lines or the flow of trucks at a distribution center. 9. Integer programming models. Integer programming models are used to solve optimization problems with discrete decision variables, such as production planning, transportation allocation, or supplier selection. 10. Game theory models. Game theory models analyze the strategic interactions between different entities in the supply chain, such as suppliers and customers, to understand the outcomes of their decisions and determine optimal strategies. 11. Multi-objective optimization models. These models consider multiple conflicting objectives, such as cost minimization, service level maximization, and carbon footprint reduction, to find trade-off solutions that balance these objectives. 12. Decision support systems, DSS. DSS combine various modeling techniques with data analytics and decision-making algorithms to provide decision support and insights for supply chain management. 13. Heuristic and rule-based models. Heuristic and rule-based models use predefined rules or algorithms to guide decision-making in the supply chain, particularly when dealing with complex or real-time situations. 14. Analytic hierarchy process, AHP. AHP is a structured decision-making technique that helps in evaluating and prioritizing different criteria and alternatives in supply chain decision-making. 15. System dynamics models. System dynamics models capture the dynamic behavior and feedback loops within a supply chain system, allowing for the analysis of complex relationships and the identification of system-wide improvements. These modeling systems can be used individually or in combination to address different aspects of supply chain management and support decision-making processes.